Hi, I'm Granny, and we're going down the rabbit hole of a gravity hole in the Indian Ocean. Is gravity the same where I am as where you are? Well, evidently not. There is a very strange phenomenon in the middle of the Indian Ocean that has confused scientists for over 70 years. They call it a massive gravitational anomaly where the ocean surface dips 106 meters or more than 347 feet. Have you ever played with the altimeter on your cell phone? You can tell where you are. Well, can you imagine walking over here and it says it's, 200 feet above sea level. And then where you are, it's 50 feet above sea level. It's so different. Anyway, or take a glass of water, and if you tip it one way, the surface of the water stays even. But that is not the case in the middle of the Indian Ocean. It's mind-boggling to me. It is called the Indian Ocean Geoid Low, and I'm going to refer to it from now on, the IOGL. It is located south of Sri Lanka, and this area experiences weaker gravitational forces than anywhere else on the Earth. A geoid is a name given where an irregular, lumpy surface of the ocean reveals irregular variations in density and gravity. A geode are rocks with a cavity lined with crystals or other minerals. So, to clarify, we're talking about geoids. The IOGL was discovered in 1948 by Felix Andres Venig Maynez, a Dutch geophysicist, during a gravity survey from a ship, but more specific, a submarine. Maynez was born in The Hague in 1887, and he died at 79 years of age in 1966. In 1910, Maynez graduated in civil engineering, and the same year he started working for the Dutch Gravity Survey. Think of why it would be important for the Dutch to do this. He recognized how the current gravimeters were inaccurate, and in 1915 he wrote his dissertation on the defects of the gravimeters used at that time, and then designed a new improved one which allowed measuring gravity at sea possible. Between 1923 and 1929, the 6'6" tall Maynez squeezed into small submarines for some very uncomfortable expeditions. He wanted to discover the exact shape of the Earth. When one of his submarine expeditions was made into a movie in 1935, he became a hero of the Dutch cinema public. Maynez discovered the IOGL but couldn't explain it. For decades, scientists have struggled to make sense of this anomaly and came up with a variety of theories. Research published recently in the Geophysical Research Letters reveals that the IOGL may be linked to mantle convection processes dating back over 140 million years. The study used computer simulations, which provides the best explanation so far for this huge dip in the ocean. Check out my episodes on plate tectonics, and it'll probably help you understand this study better. You can't see gravity, but it's there. And we've all seen pictures of the Earth taken from space, and it does appear to be a round ball. But in my episodes on the moon, I shared studies of how the moon's influence on the Earth affects tides and ocean, constantly deforming the Earth. So the Earth is not really solid. Terra firma, it ain't. Plate tectonics is constantly influencing the Earth through gravitational variations resulting from uneven mass distribution beneath the Earth's surface. These variations are called geoid anomalies, which create areas where gravity is either stronger or weaker, causing sea levels to rise and fall. Anyway, according to Atreyi Ghosh, an assistant professor at the Center for Earth Sciences, Indian Institute of Science, Bangalore, India, quote, "The Indian Ocean geoid low is one of the most outstanding problems in Earth sciences. It is the lowest geoid gravity anomaly on Earth, and so far, no consensus existed regarding its source. The IOGL is still being debated by scientists because it isn't easily concluded by the result of just simple plate tectonics. Previous scientists speculated that it was caused by subducted tectonic plate sinking into the mantle, but no existing theory fully explained the scale of the anomaly until now. Quoting from this study, quote, "Researchers used geodynamic models to reconstruct the region's geological past, running simulations to track mantle activity over the last 140 million years. Their findings revealed a surprising culprit: hot, low-density material rising from the deep within the mantle, likely stemming from the African superplume, which extends eastward and ends beneath the IOGL," end quote. The African superplume, we've mentioned this before on my episodes, is a large, buoyant structure of mantle material rising from the core mantle boundary beneath East Africa, which some believe is the driving force behind the East African Rift, where Africa is splitting apart. Geophysicists believe it is a major factor in the region's volcanism and rifting. You can go and see pictures of this. Makes me think of the San Andreas Fault. Some stuff is going on there. These high-powered computer models allowed scientists to look deeper into the Earth's interior and trace the movement of materials beneath the ocean floor. These scientists discovered the, quote, "gravity low is linked to anomalous mantle activity, the pressure of lighter, hotter material stretching from a depth of 300 kilometers to 900 kilometers beneath the Indian Ocean." Now, I've mentioned lava lamps in previous episodes. If you go and find out how they are made, it will help you understand what they're talking about, because different materials and their mass, their composition, responds differently when heated, which kind of helps you visualize what's going on with subduction and some of this other stuff. Professor Ghosh states, a geoid low, quote, "a geoid low or a negative geoid anomaly could be caused by a mass deficit within the deep mantle. For instance, drop a feather and a rock at the same time and see what lands first. This mantle activity is not a random occurrence. The study suggests that the IOGL's origins may be linked to the disappearance of an ancient ocean. An ocean just disappearing. As India's landmass drifted northward over the last tens of millions of years. The Geophysical Research Letters article describes how the Indian tectonic plate wasn't always connected to Asia. 140 million years ago, an estimate of course, a vast ocean separated the two land masses. Over time, India drifted north, closing the gap and causing the oceanic plate beneath it to sink into the mantle. This subduction event likely triggered mantle plumes, we've mentioned that, bringing low-density material closer to the Earth's surface, ultimately leading to the formation of the IOGL. Quote, "The Earth is basically a lumpy potato," said Professor Ghosh. He then explained the Earth's irregular shape, plate tectonics, and convection processes help explain why gravity behaves differently across different regions of the planet. Researchers ran 19 different simulations, replicating tectonic shifts and mantle dynamics over the last 140 million years. 6 of these models resulted in a geoid low similar to the one in the Indian Ocean, including the key factor being the presence of mantle plumes around the anomaly. But 13 of the 19 simulations didn't, leaving even more questions. Is the IOGL a permanent fixture in our world? Can what happened in the Indian Ocean happen somewhere else? Could future plate movements cause it to disappear? What is the fate of the IOGL? Professor Ghosh said, quote, that all depends on how these mass anomalies in the Earth move around. It could be that it persists for a very long time, but it could also be that the plate movements will act in such a way to make it disappear a few 100 million years from today. Oh, man. Dr. Alexandro Forte, a geologist at the University of Florida, argued that the models fail to account for the massive mantle plume responsible for Reunion Island volcanic eruptions, which produced the Deccan Traps, one of the largest volcanic formations on the Earth. Reunion Island is located 420 miles east of Madagascar in the Indian Ocean. It is so interesting how we find so many contradictory anomalies in our world, and too often there are no clear answers. Our Earth is a confusing, amazing, magical place of constant entertainment. Thanks for joining me. Join me next time when Granny goes down the rabbit hole. Please subscribe and share. Thank you.